All right, we're naming acids and bases. So this has to be quick because my wife wants to set the dinner table. So here we go. Binary acids. Binary just means two, right? So that just means that you have two elements. Like at the first one, if you look at table K, all right? So it's hydrochloric acid. It's hydrogen and chlorine. If you look at the others, right, they all have polyatomics pretty much attached to them. So that's not going to be binary. These are pretty easy to name. You just add hydro to it and then add an ic to chlorine or chloride. So here you have hydrochloride, you drop the ide, add an ic. Okay, if you get confused, just go to your reference table and look it up. If this was the Regents, you would just go to your reference table because probably by the time June came along, you wouldn't remember these silly rules. Hydrobromide, right? Hydrogen and bromine. So then you have hydro plus bromide, drop the ide, add in ic. It would be called, come on, say it out loud. Nope, I'm waiting. There you go. Okay, good. Hydrobromic acid. H2SO4, even though it's H2, it's still binary because it's two elements. So then it's hydrosulfide, drop the ide, add in ic. Good. Hydrosulfic acid. Sometimes we call it hydrosulfuric acid because it just sounds better. But if you wrote down hydrosulfic acid, you would not be wrong. And then finally, the last one, even though it's H3, this is how they would try to confuse you on the Regents. You're thinking like, how can it be binary? Because there's three H's. No, they're talking about just the number of elements. So hydro plus nitride, because it's nitrogen, drop the ide, add an ic. Hydronitric acid. All right, so here's how you name them, or not name them. This is how you would actually come up with their formulas, right? So you know it's hydro, you know it has to be hydrogen, you know it has to be fluorine, so it's fluoride. Hydrophosphoric, you know it's phosphorus, right? It's not a polyatomic ion because it begins with hydro. Then you have to do the ionization numbers, right? Or the oxidation numbers, and it's crisscross applesauce. So you have HF and H3P. Remember, just because there's three hydrogens, doesn't not make it binary. Binary just means the number of elements. All right. Next, we have ternary, right? So these are all attached to polyatomic. It's the hydrogen, Arrhenius rules, right? So it's H plus attached to a polyatomic. That polyatomic has to be negative because hydrogen is a plus. Notice the first polyatomic, hydronium, pretty neat, right? So here, if it ends, if you have an ic acid, that means the ion ended in ide or ate. Polyatomic that ends in us, OUS, would end in ide. I think I have on your assignment sheet, like if you ate an acid, that would be icky. Okay. Or if you said, hey, you want to eat an acid, and you'd say I'd, would you say, oh, I'd ate an acid, that would be icky. It'd be poor English as well. If I said, you want to hang out with us, and you'd say, I, okay, it's worked well in the ghetto when I worked in LA. So that's how I remember these two. Or you just go to the reference table and say, what is this thing supposed to end in? All right, so let's do a couple of these real quick. No hydro. It's a polyatomic. It's hooked to a polyatomic. So here's another way I kind of remembered it. This is kind of tedious. That helps great. Notice now NaO3 is polyatomic. How many different types of elements are there? Three. Sometimes there's more. So can't be binary. So it can't start with hydro. NaO3 is nitrate. Okay. I ate an acid. Ick. Nitric acid. HNO3, NO2. NO2 is an ite. You want to hang out with us? Ite. So it's nitrous acid. HClO3. ClO3 is chlorate, right? So you have hypochlorite, chlorite, and chlorate. So you have to be really careful with this one. Again, it's an 8 acid, chloric acid, NaO2, nitrite, ite. Want to hang out with us? Ite. Okay, OUS, nitrous, ClO2. That's a chlorite, right? Ite. You're with us. He's our ite. That's another one. Another weird way to remember it. Or just go to the reference table. CN, HCN. CN is cyanide. Ide. Okay. Ide, 8 acid. Getting weird looks from my family. Cyanic acid. Again, if we want to come up with the formulas for this, sulfuric acid and sulfurous acid. Notice there's no hydro, so it can't be sulfur. It's got to be either. Let's go back. So we look over here. It's either a sulfite or a sulfate. So if it ended in ic, it's got to be an 8 or an ide, right? An 8 acid, ide 8 acid. So SO4. The other one, so you want to hang out with us, so then you do the crisscross applesauce. I just want to look at something. I think I have the charge wrong. I do. I have the charge wrong on sulfurous acid, so disregard that. Yeah, so these numbers are all wrong. This is supposed to be 2, 1. Yeah, but that should be a -1 or a -2. And bases, naming bases are really, really easy, okay? If you're naming a base, all you have to do is you look at OH, that's the polyatomic ion hydroxide. So it's sodium plus the polyatomic sodium hydroxide. Calcium hydroxide. So you don't have to go di or anything like that, okay? Aluminum hydroxide. And that's really it. Naming bases are super, super simple. Again, remember pH stands for the power of hydronium. Water breaks down these slightly. In neutral water, the concentration is 10 times 10 to the -7. And we'll get into all of that later. And here's your pH scale. Yeah, this is all stuff we're going to do later. So we'll end at naming bases. Hope that was helpful. And I'll talk to you soon.